Again, welcome to College Algebra. In this session, we're going to talk about different types of equations and how to solve a problem using them. So our main objective is solving polynomial equations by factoring, also solving other equations by factoring, solve equations, quadratic in form, and also radical equations, and solve applications of radical equations. So we start with solving polynomial equations by factoring. So a strategy for solving polynomial equations, the first step, we should write the polynomial equation in standard form. Then we are going to arrange the terms of the polynomials in descending order based on their degrees. And their degrees, the exponent. We talk about the degree of an equation expression is the exponent of the variables. Also, we should set the polynomial equation to 0. Then we can use the zero factor theorem and solve by factoring. So we were going to see an example soon, but again, these are the steps, 2 steps. First, we have to write the polynomial equation in the standard form. Then we need to arrange the terms in polynomial based on the order of the degree. The highest degrees will come first, then we decrease, go descending order. Then we make sure we set the polynomial equation to 0. Then we can use the zero factor theorem or solve by factoring. So this is an example. Here they say we should solve by factoring the following equation. We have 6x cubed minus x squared minus 2x equal to 0. So here the first step is already done for us. The equation is in a standard form. And also we can see the degree of the variables equation is decreasing, descending order. The highest come first and the next to the end. So we are going to, first of all, look at the term, what is common here. We find out that s is common in all the 3 terms. So we take s out, then 6s cubed divided by s will give me 6s squared. S squared divided by s will give me s, 2s divided by s will left with 2. Then we can factor the trinomial using again the trinomial techniques of factoring. Here we can use the try and error method. So again, when we do it, we get 3s minus 2 and 2s plus 1. Again, we went through how to factor trinomial already. So for example, we can take the 6s squared and look for 2 terms of it, 2 factors of it. Here the best we have 3x and 2x. So 3s times 2s will give me 6s squared. Then we also take the last value minus 2 and find the 2 factor of it. Here we have positive 1 and minus 2. Now we can write this in a try and error form. For example, I'll say 6s and x, 3s and 2s, or 2s and 3s. Negative 2, I can get negative 1 and positive 2, or negative 2 and positive 1. So this value, we put it in combination, try and error. Then we do the multiplication. So when we choose 3s minus 2 and 2s plus 1, if we multiply these 2 binomial, we get 6s squared minus s minus 2. So that is the factorial. So we finish. Our first s value will be s equal to 0, with the s outside. Then the second will be 3s minus 2 equal to 0. So we find x, which will give us minus 2 cross the equal sign to be positive 2. 3 is multiplied by x, so when it crosses the equal sign, it's going to divide. So our second s value will be s equal to 2 divided by 3. Next, we have 2s plus 1 equal to 0. So s will give me 1 positive, cross the equal sign, become negative. 2 is multiplied, divide, so we get negative half. So next, solve other equations by factoring. And so here we have a power property of real numbers. Now, if we have a and b as numbers, n is an integer, then a equal to b. Here we're trying to say that an will equal to bn. Now, let's try to solve by factoring 2 x to the power 2/5 minus 5x to the power 1/5 minus 3 equal to 0. So we will solve this equation by factoring. First, we have s to the power 2/5 plus 1, then s to the power 1/5 minus 3. We do the trinomial factoring. So s to the power s 2x to the power 1/5 plus 1 equal to 0. So here s to the power 1/5 will give me negative half. Then the second s to the power 1/5 will give me 3. Then we can again continue. Our goal is to look for the value of x. We know s to the power 1/5. So we multiply by 5 to cancel 1/5. And anything we do to the left side, we have to do to the right side. And this is what we start with the power property of real numbers. If I have a equal to b, is the same as writing a to the power n equal to b to the power n. N have to be the same value. So that's the property we are using here. Since we have 1/5, I'll multiply by 5 to cancel 1/5, but I have to do the same thing to the right side to balance the equation. So here s will give us negative 1 divided by 32. 2 to the power 5 will give me 32. 1 to the power 5 will still give me 1. Or the second answer, we have s 1/5 equal to 3. So we multiply both sides of the expression by 5. And 3 to the power 5 will give me 243. Again, the example we are doing here is based on this rule. Power property of real numbers. If I have a equal to b, and I have n, let's say n value, I can raise a to the power n equal to b to the power n. It's the same as a equal to b. As far as n, the two n is the same. So a to the power 2 equal to b to the power 2 is the same as writing a equal to b. The powers balance each other. So let's go to the next question. Solving equations, this time in a quadratic form. So we can write the equation in the form of au squared plus bu plus c equal to 0. We already went through quadratic equation. Again, this is quadratic equation. Quadratic equation is having a trinomial, and the first degree variable should be 2. Then we have quadratic equation. Now you will say where a is not equal to 0, so a can never be 0, at least 1. And u is an algebraic expression involving x. So we can do this by making appropriate substitution. For example, I have here 2x to the power 2/5 minus 5x to the power 1/5 minus 3 equal to 0. And now, instead of doing what we did previously, I can represent x 1/5 by u. So I'm going to substitute the equation, then I write 2u squared is 1/5, so we still have 2/5, so it will be u squared minus 5u minus 3 equal to 0. So I can solve this problem using the quadratic equation or formula or factoring. Then after I get my answer for u, I will say that the answer of, let's say, u is 5. So I'll say 5 equal to x to the power 1/5. Then I'll multiply both expression left side and right side of the equal sign by 5 so that we can look for x. The same thing applies to the second question. We have 9x minus 6x to the power half plus 1 equal to 0. I can say s raised to the power half equal to u. Now, since this is half, we are going, the u square here, the u, s will be squared then. So that's why we have 9u squared minus 6u plus 1. Because u is s to the power half. So twice of x will give me the u squared. Twice of u will give me x. So that's why it's u squared. So let's see an example now. So we have 2x to the power 2/5 minus 5x to the power 1/5 minus 3. Previously, how we solve this one, we try our best to factorize using 2/5, but it's very difficult. The best way to do this is substitute. In this case, we say u equal to s1/5. So if u equal to s1/5, then u square will be s2/5. U square is s2/5. So now I'll write as 2u squared minus 5u minus 3 equal to 0. Now when I find the value of u finish, I'm going to substitute here to find the x. So now this is easier to factorize. When we factorize this trinomial, we get 2u plus 1, u minus 3. So 2u plus 1 equal to 0, then u will give me negative half. U minus 3 equal to 0, u will give me 3. We have not finished yet. We just find the value of u. Now I will say s1/5 equal to negative half and another x. We use u minus 3. So let's say the next step, s1/5 equal to negative half because u is half. So now we multiply both exponent by 5 to get the value of x. 2 to the power 5 will give me 32. 1 to the power 5 will give me 1. So our answer will be s equal to 1, negative 1 by 32. The other one, we have u equal to 3. So s1/5 equal to 3. Multiply both equation by 5. And s gives us 243. Now let's solve a radical equation. We say the strategy for solving radical equation with square roots or cube root. The first step, make sure we isolate one radical on the left side of the equation. Then we are going to raise both sides of the equation to the same power. Now, if the radical is a square root, then we square both sides. If the radical is a cube root, then we cube both sides. Now, if the radical remains, then we repeat both step 1 and 2 again until we remove them. Then we solve the resulting equation and check our answers. So let's see example. We are going to follow the steps here. So this is a radical equation. We have a square root of s plus 3 minus 4 equal to 7. Our goal is to find the value of x. So we write down the equation here. Minus 4 is outside the square roots, the radical sign. So we can bring it to the right side and add it to 7. So we get 11. Now we remember this rule said if we have a radical sign in one of the side, or in this case the left side, it's a square root, so we're going to square both sides. If it's a cube root, we cube both sides. If it's fourth, the same thing, fifth, etc. So since this is a square root, we square both sides, and we were able to remove the radical sign, so we get s plus 3. Why? Because the radical sign means square root of half. Now, square root means half, exponent half. So if I have a square and I have a half also, half times 2 will give me 1. So that's why always square root will cancel square. Same thing, cube root always will cancel cube. So in this case, s will give us 118. Now we want to check the answer if it's correct. So we substitute 118 for x. We have square root of 121, 118 plus 3, 121. And that gives us 11. 11 minus 4 is 7. Okay, that's correct. 7 equal to 7. Now the last example, let's solve applications of radical equations. So here we have an highway curve. Bank at 8 degrees will accommodate traffic travel s miles per hour if the radius of the curve is r feet. According to the formula, s equal to 1.45 square root of r. So find what radius is necessary to accommodate 70 miles per hour traffic. So here we can see the r radius, the speed 70 miles per hour, and also we say the curve is 8 degree curve. So in this case, we know the formula is given to us s equal to 1.545 square root of r. S is 70, the speed, equal to 1.45 square root of r. So 1.45 is multiply, cross the equal sign is going to divide. Now we square both sides to remove the square root, so R will give us 2,330. So the radius of the curve is approximately 2,331. So again, this will be the conclusion of our lectures. And in these lectures, again, we went through how to solve radical problems, factorizing problems, using some few strategies to solve them. Again, if you have any question, you can send an email. Then wish all the class the best. Thank you.